Welcome back everyone to the Combinatorics and Probability Week on my WhatsApp and Facebook groups. I know what you must be thinking. This does not look like a GMAT standard question, and that is by design. I apologize. I wanted to bring this concept of with replacement, without replacement simultaneously, and this is the best way I could think of bringing all of these concepts together so that you understand that they are slightly different and there are nuances around them. And with this one example, understand how different questions can be solved differently. In fact, as a bonus, I will also add another item to the same question so that you have a better understanding of what else can be asked in this particular topic. So let's get started. As you can see, I have added another probability of n, which is getting the events of red balls, blue balls, and a red ball in a particular order. And how does that change what we do and how we solve this question actually matters. Okay, so the four broad categories that can be asked is one by one without any replacement. So you're picking balls one by one and not replacing them. So first time you have 10 balls, you take one out and now you have only 9 balls remaining. Then the other variation of this could be you replace the ball back and then take out the second ball. And as you can imagine, the probabilities and permutations, the probabilities would obviously change because the second time you would again have 10 balls to choose from. Simultaneously is a variation of one by one without replacement. It actually doesn't change the answer but confuses a lot of people. Simultaneous means instead of picking them one by one without replacement, you are just putting your hand in and taking two balls. And technically, it doesn't matter. I will show you that mathematics backs that it doesn't matter. However, in your mind, you should think about simultaneous as even though you're picking both of them together, there may be a nanosecond of difference between picking the first ball and the second ball with your fingers. So it is same as picking one by one without replacement. As you can see, the answers would be consistent. And finally, having a specific order. And in this case, the order is given to be a red ball, then a blue ball, and then a red ball. That is another type of question that is asked in GMAT. I have deliberately kept the answer choices very simple because the concept and the approach here is very important. Not getting confused here is very important. Once you understand the approaches and the concepts and the difference between these four items, you would be able to handle a lot of problems as long as you are able to categorize. When you look at the problem, you're able to categorize between these four. Okay, so let's get started. Before we go, if you like this video and find it helpful, please do not forget to press like and subscribe to my channel. It helps me a lot and keeps me motivated to bring more and more videos to you. All right, so we all understand what picking one by one without replacement means. Now, how could we pick two red balls and one blue ball without replacement? Let's think about the order first. So we could actually pick out one red ball first, another red ball first, and then a blue ball. We could pick out one red ball, one blue ball, and one red ball. Or we could have picked one blue ball first, another red ball, and another red ball. All of these three would all fall under the fact that we want two red balls and one blue ball. So we have to combine these three probabilities to get to the probability of two red balls and one blue ball. Since there is no replacement, getting this probability would be taking the first ball out, which would be a red ball. Since there are 6 red balls, you have a choice of picking a red ball in 6 ways. So that would be 6, and total number of balls is 10. So it will be divided by 10 multiplied by another red ball. So now the number of red balls has reduced from 6 to 5. So we will take 5. Since the number of total balls has also reduced, since we have not done a replacement, it would be multiplied by 5 by 9. And finally, we want to pick a blue ball out of the 4 blue balls available to us, but total number of balls at this time is only 8. Similarly, you can quickly do these two: 6 by 10, 4 by 9, and 5 by 8. So one thing you should be able to quickly notice, even though I have changed the orders and these are separate events, so they cannot actually happen at the same time, the probabilities would have to be added up. The numerator are 6, 5, 4 and the denominators are 10, 9, 8. in each of the cases. So they are basically the same probabilities, and that makes sense. Why would probability of RRB would be any difference than BRR when you are picking the balls? So that actually gives me addition of these three possibilities, and that would be 3 multiplied by this number, which gives you 1 by 2 as my overall possibility of getting 2 red balls and 1 blue ball. Now, I'm going to quickly tackle probability of n because it is about getting a specific order, and in this case the order was a red ball, a blue ball, and then a red ball, which is order number 2. So since here the order is important, the number of possibilities of getting RBR is less than overall possibilities of getting either the red balls or the blue balls in any order. There is only one specific order, which is order number 2. So in this case, the possibility which is equal to 1 by 6. It may be a little counterintuitive, and this may be what trips you up in the exam. In permutations and combinations, when the order was important, we actually got more number of ways, right? So here, even though the order is important, it is one specific way of doing things, not any number of doing things. So here order is important, but it's a very specific order, not any order or any way of arranging them. Okay, so now I'm going to jump into simultaneous because it is very similar to X done differently. In simultaneous, what I'm saying is, okay, I need 2 red balls and I need 1 blue ball. I don't really care how I select them, but I need this selection and I have to select 3 balls. So let's think about it in a favorable outcomes divided by total outcomes. For me, the total outcomes is selecting 3 balls out of 10. That's it, right? It doesn't matter what color they are and what is the order. It is 10C3. Now the favorable outcomes is out of the 6 balls, I am selecting 2, and out of the 4 blue balls, I am selecting 1. So that would be 6C2 multiplied by 4C1. One way that you should quickly think about to cross-check if you're doing this calculation right in the exam is this 6 plus 4 must be equal to 10. That way you make sure that you are actually calculating the total number of balls correctly. And whatever choice you are making, 2 plus 1 should be equal to 3. If those are not matching, that means you have made a mistake. It is better to catch yourself and actually don't do that mistake. Catch yourself and correct yourself at that time. Okay, so that results in 60 by 120. That is actually equal to 1 by 2 as well. So as you can see, 1 by 1 without replacement is same as picking them up simultaneously. It would give you the results at the same time. There is some debate around, do we consider order when we are doing simultaneous, or should we divide it by half or 1 by third, whatever the case may be. However, in pure mathematics, simultaneous and picking 1 by 1 always yield the same result, and that is what you should know. And finally, we come to this 1 by 1 replacement. Now 1 by 1 replacement is very easy to calculate. All you have to do is, again, we have to consider 3 different possibilities, and the possibility of getting a red the first time would be 6 divided by 10. Now I am replacing the ball, so the next possibility would again be 6 by 10, and finally getting a blue ball from 10 is again 4 by 10. There will be no difference in this one, and similarly resulting in a probability of 0.432. Now intuitively or quantitatively, if you were going to reason, you know that the probability of doing the replacement would be less than without the replacement, because the denominator is higher for every event. By reasoning, you would know that always x would be greater than y. And what we have just found out is that x is greater than y, and also x is equal to z. And if we go back to the answer choices, x is equal to z, and we know that x is greater than y, which means z will be greater than y as well. So the answer A is the correct choice here. I hope this will help you solve the probability and permutations combinations better. If this has helped you, and if you have any other comments, please feel free to put it in the comment box. I personally respond to all the comments. I hope I made you get a little better today than you were yesterday. All the best with your GMAT prep.